Fantastic. Okay, well let's get the party started. We have Will Squires up here on the stage, and Stefan from Macrocosmos, as well as the Tensorplex team, to talk about Macrocosmos in general, but also specifically Subnet 9 and some of the amazing results that we've seen over the last little while. And I'll pass the mic to you here, Will, and let you MC this for us.
Yeah, so thanks for having us, Jake. I'm Will from Macrocosmos. I guess for those of you who don't know, we're a team that's formed from the original Subnet 1 team. Stefan, my co-founder, who'll speak in a moment, was the CTO of the foundation for a period. We're sort of coming out of stealth and have been over the last 2 or 3 weeks. I'm really excited to do this novelty search. I tried to do one a few weeks ago when we had a bit of a chaos in Peru when the connection collapsed. But we're really excited to talk about some of the developments on Subnet 9, celebrate some of the work that Tensorplex and the others have done as the winners of the sort of active competition that is decentralized AI on Bittensor, and also share a little bit more about what we're doing at Macrocosmos, what we're hoping to do in the future, and ultimately just celebrate, I think, the excitement of what's going on in this protocol today. Steph, I don't know if you want to add anything.
I think you covered it pretty well. The main thing here, guys, is this is kind of Tensorplex's call as much as it's ours. Really, I want to make sure they get as much time and space to talk as they want. They've done an awesome job on Subnet 9. So massive congrats to them. Yeah.
So I want to touch into how Macrocosmos came to be, because I think it's interesting and relevant. So Macrocosmos is a spin-off, or like we cut off our Synapse team at OpenTensor and wanted to take that team that was primarily responsible for building the mechanism design of Subnet 1 before Subnet launch in October. And so Stefan was the lead of that team, Crux here on the stage. And we said, hey, well, it doesn't make sense for OpenTensor to have this team internal because we're a not-for-profit organization, and we want to compete in this game that we've produced, this market, where there's no conflict of interest. And who better to take that on than Crux here on stage, who was behind the scenes at OpenTensor for the year before. So a year ago, he was fighting the miners, and now he's doing it again, but on a bigger scale across multiple subnets at Macrocosmos. So tell us a little bit about this, like Macrocosmos, like who you guys are, what's your background, aside from OpenTensor, and then we'll also do the same thing for Tensorplex.
So I think I'll start with that. Look, I'm Will. My background's originally I was a civil engineer. I started building nuclear power plants and then moved into tech and AI. I've been building tech businesses and AI businesses for 10 years, both in FTSE 100 and in startups. And at Macrocosmos, we're really trying to be, I think, 2 things. One is a really serious team, bringing a lot of structure and organizational effort and professionalism to how we build subnets and how we build Bittensor ultimately. But secondarily, a team that's really here to do a lot of the deep work on driving the intelligence component that is necessary for Bittensor to compete with centralized solutions. And a lot of our core team, and I can see Ferpe and Elasmir and some of the others on the call, are phenomenal engineers and phenomenal sort of AI specialists. But we're very excited that a broader team has grown. We've ramped from sort of the 4 or 5 team in the foundation to, I believe, 20 today, and we're still going. So the likes of Curiosity on the call, Roel, I think Cryptal might be on there, but we're growing at scale. And I think that's sort of testament to our vision and our confidence in what Bittensor can do, but also the fact that we think we can help raise the game. And we're really excited to see how teams that are sort of, I guess the original basis for a subnet team was a couple guys doing brilliant things. We want to see what big teams of people can do when they really bring some firepower and intellect together. And I'll pass to Stefan to sort of add a little bit of flavor to that, but we're very excited to be here talking about Subnet 9, which we've been working with the brilliant Sid and Rustic, who've been the sort of shepherds of that for a period. But if you're following the IOTA channel, you'd have seen we're sort of formally taking over today. And just keep pushing the boundaries of what's possible on Bittensor, both in a competitive sense, but also in terms of what incentive mechanisms need to evolve to to make this the world's most powerful decentralized supercomputer?
From me, I am first and foremost a researcher. So my background is very academic. I have a PhD in subatomic physics. So while Will was building nuclear power plants, I was making nuclear explosions, I guess you could say. And it's been a really fun ride going from research into more applied AI in the private sector, starting to do what we're doing in Bittensor. I'm really, really excited to see what happens when we've got the resources that we need to actually do the deep research that's necessary. And really, yeah, Macrocosmos was birthed because Will and I are very old friends. We've been sort of threatening to start something together for about 15 years, and Bittensor was the perfect excuse to build something together. So I guess I'll leave it there for you, Const.
Thank you. But also I want to hear from the amazing intros, by the way. Thank guys. I hear from the Tensorplex side of things. Like it's kind of a holy union here between the subnet and the miners on stage.
Yeah, sure. Hey guys, yeah, thanks for having me on board. I'm Expo, one of the co-founders at Tensorplex, and we're building a suite of products on top of Tensor, such as a liquid staking token on Ethereum. We're also running a validator, and we're launching a subnet very soon. We'll release more details about this in the coming weeks. So a bit of background of myself. I was previously studying aerospace engineering, but I have been working in AI for a bit, building convolutional neural networks for 3D model feature detection. And at Tensorplex, I manage the various development operations. And for today's call, I'll let Sinking Ship take this, as he is the lead for our machine learning operations on Subnet 9.
Hi, thanks. So yeah, I'm currently the director of AI at Tensorplex. I do most of the things that's related to AI. And a bit of my background is I also come from a academic background. I have a master's in AI. Most of my research is about language models and NLP. I did like controllable generation, looking into the language model activations and try to fix them, things like that. And been working on some large language model pre-training or fine-tuning, many different cool projects like very new architectures, and yeah, all of that kind of applied to what we do in Subnet 9, and it's all very exciting for the past few months.
We're going to get into how you guys beat Subnet 9 or are winning. I guess there's no beating Subnet 9 really, because the loss just goes down to 0. And that will never happen. We're always going to be scraping more and more productivity out of the models. But let's go back into a bit of the history of Subnet 9. It was created by Fish and myself initially with the goal of training foundation models. It's still doing that, and then it was given over to Rustic and Sid, fantastic engineers that have been, as Will mentioned on the stage, shepherding it, improving it, making it so that the core mechanism really works. And we started with really small models. I think it was 500 million parameters. Then we moved up to 1 billion parameters, and then it was 3 billion, and we're currently at 7 billion. I'm sure we'll talk about this a bit later. But what is it in your mind, throwing the stick over to Tensorplex, like what is it that interested you guys about mining on Subnet 9 specifically?
So yeah, it was primarily my idea to get into Subnet 9. So basically, at that time, it was kind of for us the most straightforward subnet because it has a very simple incentive mechanism, like you bid all and you get the money, right? And the incentive mechanism and the validation mechanism itself was very hard to cheat, right? You have to load your model, and there's no way you can change the code to load the model. Like the validation, the process is all baked into the code, so there isn't much to cheat. And another thing was, at the time the models were very small. I believe when we came into the subnet, it was like 183 million parameters at the time, and the the registration fee was also very cheap at the time. So all these things together, we were like, this seems like a very, very interesting game to play. And yeah, we thought we had the experience to, shine in this subnet. So we kind of dive into it right away.
So sinking ship, can you give us like an explanation of how Subnet 9 validation mechanism works?
Yeah, absolutely. So basically, currently we have this large data set called Refined Web, developed by the United Emirates, right? And so basically, what they do is the validators randomly sample a subpage of this large data set, and you compute the loss on each of the documents for every different models that have been uploaded to the subnet, and then you compare those loss of different models head to head, and take a look at the win rate, and those who win the most gets the top spot.
There's some other aspects to it that, so exactly right. The miners, what they do is they submit a trained model to Hugging Face and then write a commit message to the chain saying, hey, this is the model associated with my UID, and here's the hash of the model so that we know that it is in fact their model. And what the validators do is they pick up the models from Hugging Face by scanning the UIDs, finding the associated Hugging Face links, and then pulling them onto their local machines, and then running effectively like a micro eval on an extremely large unlabeled corpus of text. I think it's like 6 trillion tokens. Am I correct?
I'm not entirely sure. It should be like 3 trillion. Yeah.
3 trillion. Okay. It's 3 trillion tokens. And the goal of the models is to be able to, so the goal of the miners is to train a foundation model specifically, which can predict the next token in the text. And this process of just being able to predict the next token given the previous sequence is what is used to effectively compress the 3 trillion tokens into the model's parameters such that it has a deep understanding of basically everything and then can be fine-tuned to create things like ChatGPT or Llama is an example of this type of model, or all of the news subnet models are effectively fine-tunings of the general knowledge that is pre-trained, hence pre-training or foundation model training, given this process. It's the most expensive computational problem in AI. I'm right there, right?
Yep, that sounds about right.
We'll get to exactly how you guys, how much compute you guys used. I'm really curious about this. But anyway, so the miners submit these models, they train them on Falcon, and then the validators, they evaluate them for their ability to do this next token prediction, and it's measured in terms of perplexity, which is effectively it's a cross entropy metric. It's it's the exponent of the cross entropy, the loss. It's the cross entropy to the e to the power of the cross entropy.
That's the perplexity part, right?
Yeah,
The
exactly.
loss
The
itself
perplexity.
is just the log probability. Yeah.
Yeah, exactly. The cross entropy. And anyway, so the now there's one of the interesting things about this subnet. I want you to talk about this sinking ship is so obviously miners are going to cheat. They're going to steal each other's model. So what's been like the way that we approached this problem was that there would be a time stamped reward for producing a model earlier than other participants, as in like your loss, you'd get a decrease, like a boost in your score, or a boost in your loss, for having an earlier model submitted to the chain, right? So that's an important aspect because it doesn't, even though you can submit a model and have that model just be a copy of someone else's model, in practice, it doesn't help you because they've got a boost by submitting it earlier on the chain.
Yep. So it's just like if you're not winning against another model until you are 0.5% better or you're earlier than the other model. So if you copy the model from another person, you will have to improve it by at least 0.5% than the other guys. So it kind of gives you advantage to against the copiers who will just copy anything and submit it to the system.
So let's go through what happened and like how the subnet has progressed. You guys have been on the other side, the flip side, you could say, of the subnet, mining it from the beginning. Tell us a story about how that mechanism has played out over time.
Yeah. So I think the first time we went into the Subnet was in January, I think. And at that time, it was a very smaller model and about 183 million parameters. And after we submitted, and I think we submitted just a single model at the time. And then after it got into the top spot, we found out that people will be copying our models, and then there are only a few spots at the top. So it only makes sense to submit the copies ourselves, right? And that's been going on since that ever on. So everyone, when they get the top model, they submit multiple models, and yeah, that's been happening all the time. And regarding the validation mechanism, there has been, I remember just one particular time when there was like an exploit of some sort, where the guys who found out there are some specific models that allowed them to trick the validation system and get a lower loss, and they could beat everybody else with nearly zero losses, and we kind of get around it too. And yeah, and what else?
Well,
What's the
let's talk,
question?
yeah, let's talk about the model that I think is why that we call this call in the first place.
Mhm.
Like, Will, maybe to you, like, let's talk about the heading here.
With Subnet 9, I always go back to the first time I read the original Bittensor white paper, which had these sort of three core concepts. One was market forces can organize compute. The second was decentralized training is a possible concept. And the third was teams with a competitive incentive can beat everything. And I think the model we see today is absolute proof of that. Not only have the model that Tensorplex have put together beaten Falcon 7 billion at its own game. And again, we should just pause and celebrate that for a moment. The Sumo Tau 9 model is better than the original model trained by the Saudi team that did this. But they've also proved they can beat fine-tuned versions of Llama 2 as on Subnet 6. And that is really, really, really cool. And again, sometimes perhaps it's easier to just say, this is genuinely cool, guys. This is genuinely like a big proof of, Const, not to buddy you up, but some of the underlying principles that were in that white paper. And I'll pass to Steph to talk some more about the technical specifics, but I think it's an amazing precursor for what we can do on Bittensor as we push the competition on Subnet 9. And we'll talk a little bit more about that later, but I'll hand over to Crux for a moment.
Yes, something else that I would highlight about what's so cool about this result is Tensorplex guys didn't just win one round of validation, so to speak. Because everyone can copy their best model by design, to stay ahead, they have to out-innovate everyone at every single step, which is just mind-blowing. These guys have not just fluked it. Every day, they're basically battling to keep their crown as the kings of Subnet 9, and they're showing us that they can do it. So it really is a testament to the fact that we have been able to absorb a really, really talented LLM pre-training team into Bittensor because of the incentive mechanism that unlocked it. So it's huge. Look, we're all really, really excited about this right now.
Is the model getting better every day, sinking ship and Darwin?
By every day, do you mean we are keep training on the model? That is
Yeah.
true, and we see improvements definitely, but the improvements currently, it's very incremental at this point. But it's definitely getting better every day. We see different scores on leaderboards and different losses every day. But yeah, I mean, if you look at only on the chain, it might be a little difficult to see that, but we see that it's getting better every day.
which is really, really incredible, right? So are you guys submitting newer models like continuously at this point? Like when's the last time that Tensorplex submitted a model?
I think the last time we submitted was like 2 weeks ago. The thing is, we cannot submit a better model right now because if we do, we're going to lose our top spot.
Right. Right. So you don't want to submit a model on the same UID because then you lose your you lose your block like
Advantage,
boost.
definitely.
Right.
Yep.
But are there like minnows nipping at your heels here, like other people that are training off your model, just trying to get that 1.5% edge on the top?
Yeah, we see some people trying to, further train our model, and there are some people doing that, but we haven't seen anyone not yet up to 0.5% yet.
It's so wild. You're right, Stefan. Like when we first thought about, hey, let's use incentives to work on machine learning problems, the primitive is, hey, can markets help us do things more efficiently? And I think this really is a good showcase of how that can happen in practice. It's a little bit. It's funny when you talk about like how the market mechanism has been really helpful for Bittensor to train this model with the use of Tensorplex. It's kind of like a objectification of the Tensorplex team. It's like we incentivized you into existence, guys. And you did such an amazing job. But do you think that do you see that maybe the incentive design actually improved your ability to push the loss down on this model? Like it actually helped you guys, and in what way did it help?
Yeah, absolutely. I think it definitely helped. I mean, forced us to push the loss down, right? Because otherwise, we won't be at the top. And I think the one a pinnacle example of this would be the time when we go from 1B to 7B. So during that time, there was about 2 weeks or 3 weeks of lead time between that update period, and at that time, everyone's in the dark, right? No one knows what we're fighting against. No one knows what other people have lost for their own 7B models. We definitely know they are training their model, right? So at that time, we have to do whatever we can to get the best possible model possible, right? So we tried various different approaches, a lot of different experiments, try to get the best possible model we can because we don't know what we're fighting against. So it definitely helped us to, put our most effort into it and just try to get the better model every step.
Let's talk about I know that before the call you guys said you don't really want to talk exactly about all of your methods. What can you guys tell us about how you trained this model so well?
So I think one very important and interesting idea we got out of this training subnet is about architecture design or how we allocate the parameters. So in the earlier stages where the parameter requirement were much smaller than now, we kind of thought that deeper models would be better. And it was actually. Deeper models were preferred over wider models at the time. So what we did was we kind of looked at what other people did and what other models at the same size did and tried to make it a little deeper by making a little narrower, right? Like have a little less embedding size and having more layers. That's the approach we took, and it actually worked out very well. But then at some point, I believe it was 1B at the time, and we found out that after some point, having enough width is very, very important. That kind of extra width in the embedding dimension and the MLP dimension, those kind of width is very, very important. And increasing them over increasing the depth of the number of layers of the network is very, very important for the loss. So that's one thing we would like to share today. And in terms of hyperparameters and stuff, we found out having a, you know, it's been out there all the time. A lot of people who are training large models say it, but learning rate is the most important one. And
Interesting.
we put a lot of time to tune the correct learning rate and try to put all different experiments and different papers that come out every day to get the best hyperparameter as possible.
I think another interesting way to think about the Subnet 9 design is kind of like a collaborative genetic search algorithm. There's a fitness that's defined at every step, and since the best model gets inevitably cloned and everyone sort of rebases onto that best performing model head, we're kind of just doing a hyperparameter search in real time, guys, and you're a proof of that. You're basically showing that the fitness function changes with the data set, changes with the sort of the weights limit. It's a really interesting way to explore a very vast and complex space, and I think Subnet 9 has a really elegant incentive mechanism, and it's really been a 0 to 1 moment in terms of the research that Bittensor is doing at large here. And this often happens in research. Sometimes it's incremental progress. Sometimes it's sort of a distinct 0 to 1 moment. And I think that the fact that there's no moat, right? As soon as you submit your model, it's everyone's model. So what have you got next? How do you stay ahead? And this has actually inspired an entire generation of subnets that sort of they use the same winner-takes-all mechanisms, and they also make use of the same rebase mechanisms where the sort of copying is sort of baked into the DNA of a subnet. At Macrocosmos, we actually dropped a subnet earlier this week for protein folding, and look, a lot of the design turned out to be so suitable for the problem of protein folding, which is a different beast. It's a different kind of optimization problem, but they're similar in striking and unexpected ways. For example, there's jobs that can take hours or days or even weeks. Some very large proteins, it's sort of an exponential time problem. And we had to think a lot about how do we apply the lessons learned from Subnet 9 and the sort of optimal strategies that are birthed as a result of the incentive mechanism, and how do we use that to drive different types of competitions too. So really, really interesting to think about how you guys had to continuously out-innovate everyone else. Really, really cool. Just congrats again, guys. Take a bow.
That's like Bittensor in action. If the subnet doesn't have that, there's a big problem, right? If it's not this game where if if it's a game that you can just win, right? Like there's no point in using Bittensor to do it. The subnet should shut down as soon as it's solved. It's really, really good if the incentive landscape kind of just goes continuously in one direction, and someone can always do a bit better. And that's how you that's where Bittensor actually becomes efficient and something that's worthwhile as a machine. Like only when there are designs that have this quality of a continuous improvement, of hyper competition. Yeah, the never ending story. Thanks, Mars. So yeah, like let's talk about where I had one question also, which was how much compute. And this is maybe a bit of a selfish question because I want to know how big we can go here. Like, how much compute did you guys use to train this model? And how big do you think we can go in the next 6 months? Like, can we hit 100 billion parameter model on this subnet? Trillion? And what do you think? Did I just ruin your day, sinking ship?
Nah, not at all. I'm not sure if you can give us the exact number, but we're just gonna say when we were doing 700 million, we didn't have a very big cluster. At that time, we had like um 800s at the time. And after moving to 7B, we are quite a bit bigger than that.
And can you tell us about your cluster size?
At least the double of that.
Cool. Cool. I mean, and one of the things that's interesting about, like, say, you could say this is a bit like a Kaggle competition, but it's an incentivized Kaggle competition, which means that as we increase the model size slowly, teams like yourselves are also being rewarded. You're being funded to increase your cluster sizes. You're being paid as you reduce the loss. And I think that when we were originally talking about this subnet, like we think like, what exactly is the thing that you're optimizing here? And it's a lot about compute optimization, right? So my guess is you guys don't have 4,000 H100s. Well, that's how many
Yeah,
GPUs,
not that much.
right? That's how many GPUs it took to train Llama 2, which you guys beat last week.
Mhm.
So maybe give us a factor here. Like what was the actual compute resource efficiency that we got roughly? I mean, you can't tell us exactly how many GPUs you have, but what are we 10 factors? Are we 10-fold away from 4,000 GPUs in order to train our equivalent model?
Let me calculate.
And then just add
4,000. Almost like 50x difference, I think.
a yes, right? That's pretty incredible.
That's crazy.
Yeah. So I mean, you guys have different techniques, and we're a couple years ahead of Llama 2, but a 50x, like who would have thought that just incentivized computing would get a 50x improvement on something? It just tells you how shit bureaucracies are. Corporations
True.
suck. And you guys are like micro corporation. We're all like little micro corporations inside this bigger wetware corporation. So I mean, that was, you go on.
One of the things you asked earlier was, what's the target for Subnet 9? And I think when we look at it, maybe a little bit selfishly as Macrocosmos, as part of that wetware corporation, is, this week we deployed Llama 70 billion as the validator on Subnet 1. So the best open source model we can get for an economic price. We want Sumo Tau 70 billion being the threshold of open intelligence that drives the intellect of Subnet 1. We want a Bittensor trained model defining what open source decentralized intelligence can do on Bittensor. And that sort of, from our perspective, is a little bit of what we want to do at Macrocosmos. We want to show that Bittensor can do the end-to-end of cutting-edge, state-of-the-art intelligence. And guys, I hope you can make a 50 times factor improvement on that compute cost.
Yeah, we hope so too.
That's awesome. And so am I hearing 70 billion in next week?
Well, we've got some we've got some pretty grand plans. We're prepared to share a couple of them. So as Will alluded to at the beginning of the call, we've been quietly staffing up the team behind Subnet 9. Of course, we're going to continue working with the awesome Sid and Rustic, but we've now got an army of AI PhDs also in the background. Some of them are on this call, in fact. And we've decided what we want to do immediately next is a major upgrade to the dataset. So from the Falcon dataset to the new dataset, which is called FineWeb, which I'm sure miners are immediately starting to train on as I say these words. So it's basically 5 times bigger, but it's using state-of-the-art pre-processing techniques, deduplication. So it's just much, much higher quality. And what we expect to see here, and we've been running benchmarks internally for a couple of weeks that we're going to share some results with in the next few days. We're seeing that the Tensorplex guys and anyone else on that subnet, we can basically squeeze a lot more drops out of that lemon just at the current competition. And I think that's the flex we're going for right now. We want to show at 70 billion, at 7 billion, we're not even done yet. We'll go to 70 billion in time, but right now, we kind of want to just embarrass all of the centralized approaches to this right now. We're not done yet. So data set improvements to come. We're looking at heterogeneous mixes of data sets as well, so we can actually evaluate on multiple different data sets so that we don't just sort of overfit to one scenario. We've got a much more, I'd say, interesting and sensitive evaluation benchmarking pipeline as well, so we can really direct the efforts of the miners, not just for loss, but anything that we care about within the properties and the qualities of those pre-trained models. So that's coming down the pipeline really, really soon. Our team's going to start making some announcements to that effect, but you heard it here first. We're going to be changing the data set very, very shortly, and we hope that that's going to sort of invigorate, let's say, the next round of Subnet 9's great competition.
We should just increase the billion parameter cap like every block or something. I don't know.
Not a bad
every
idea,
day.
Const.
Yeah. Just make it a continuous thing. It's like, okay, by the end of July it'll be 7 billion, but the next day it'll be 71 billion. And why stop there? I don't know. That might be.
Sinking ship is having an aneurysm right now when thinking about his compute clusters.
Yeah, maybe it's not such a good idea. It just makes it more complex. I don't know. What do you think about that sinking ship?
Obviously, going to be very challenging for us. I mean, it's very hard to. One of the hard problems in AI or LLM would be scaling. And then what I mean by that is how do we use the smaller model to start off with a bigger model? It's a very unsolved problem. And increments of 1 billion at a time would be very, very challenging. But I think overall it's an interesting idea, right? It also forces us and also incentivizes us to solve a very interesting and hard question in AI. So in a way, it's a good thing, but yeah, definitely a hard problem for us to solve.
Yeah, we don't want to make it too complex, because one of the things that's really good about this subnet, I think, is how well defined the validation problem is. Like if you know that if you train the best model on Falcon, then you will get the best score, and you can get your own infrastructure and organize that and allocate the compute, and you have some time, and so I think that in the progression of the subnet, I hope that, yeah, it's not about ripping the Band-Aid off too fast. It's about moving slowly with clear goals and allowing people to adapt to the new market.
Look, as much as this is Tensorplex's moment more than anything else, you guys should know that Will and I are actually sitting on the 7th floor of a WeWork in downtown London right now. We can literally see the DeepMind office, and they're still in the office, guys. And we're going to go there straight after this call, and we're going to tell them to stop mining Subnet 9. So enjoy your moment.
Oh, really?
We're
Try me.
very,
Try
very
me.
convincing when we need to be.
Maybe a couple beers will help get that across the finish line. Fantastic. So let's talk a little bit more about so one question I have, and I think this is a little bit less of a positive note, and I think the biggest critique with Subnet 9 is around endgame monetization. And is Macrocosmos thinking about where they can take Subnet 9 in such a way that it makes sense from a validator in the subnet to want to be there and do the validation process? What monetizes Subnet 9 effectively, in short?
Absolutely. Look, as we speak, Subnet 1 is being plugged into some really great front ends through its API. And what we see here, and sort of one of the superpowers of Bittensor, is the natural interconnectivity of subnets. And what we want to see is really Subnet 9 is the fuel that creates the fire, that forges the models that ultimately become the intelligence that emerges out of Bittensor, entirely produced in an open source and transparent way. So our vision for Subnet 9, and what we believe is uniquely important and urgent about participating in it, is actually enabling Bittensor's intelligence that people can access and talk to. It's tangible, it's useful, it's an assistant. This is something that is sort of the essential precursor to that final recipe. And what we're doing right now as well, of course, is we're trying to make Subnet 9 as visible and accessible to a wider audience as possible. And so we're sort of going back to the drawing boards with dashboards and thinking very carefully about how can we highlight and celebrate what is so wonderful and exciting about these models that are being produced by Subnet 9. There's everything from enabling people to deploy them, of course, to various ways of measuring them with respect to what currently exists out there. Subnet 9 is kind of uniquely hard in terms of communicating its value to non-technical people. So we think a really great way of just making it something that no one can ignore is actually just taking what comes out of Subnet 9, fine-tuning it, plugging it into Subnet 1, and then people can absolutely appreciate that this whole thing is created in-house in Bittensor by incentive mechanisms.
And Will, I think there was also some talk around how it would be possible for the actual the actual competition to be framed in such a way that we're training models for clients on the subnet, right? Like that could actually be done.
Yeah, so from a broader product perspective, when we look at SN9, and I think this goes actually for a lot of the next evolution and incentive mechanisms, is how do we create directability for validators and bandwidth accessors? And that's a non-trivial problem that some of the teams have already started to look at and have some great work on. But I think in 9, it's interesting. There's sort of expansion opportunities in how can 9 train not just sort of, the models it's doing today, but more multimodal models, but also how could we create specific problems for specific customers or otherwise. And, SM1 is a great example of that. It's still the first ever Bittensor subnet. We view it as a bit of a hub of innovation and incentive mechanisms. And we're trying to take some of that thinking that we took when we originally did the design of 1 back into 9 about how can we make that contest, what we've spoken about today is almost the upper bound of the contest. How can we push the maximum parameters that can be trained, that are possible? What it then becomes is how can you find a more particular niche within that search space that corresponds to a problem? Steph, I don't know if you want to pick up a little bit on how you see that evolution going now, but I think what we've seen is there's a lot of complexity in designing a training subnet system. Some of the, I guess, challenges Subnet 6 came up to are part of that. I think for us, it's about how do we add those extra layers of flexibility. We've proven Bittensor can solve the tricky problem of solving at scale. How do we start to turn that into a more directable mechanism? And we're doing a lot of thinking about that right now.
Awesome. Well, there's lots of updates coming from this subnet over the next little while, and I think that I would also want to shout out to Rustic and Sid, who are not on the stage here, where they really should be, right? Like they actually ran the subnet for the last 4 months and did an amazing job. Like if they're not in the crowd here, but they shouldn't be overlooked at all. I think you would agree.
Those guys are absolutely geniuses, and we are so stoked that they want to hang out with us strange British people and continue to build the subnet. Yeah, totally. This should be their moment. Shout out to you guys.
It's important to note that they're still heavily involved in 9. They're guys who don't like being on podcasts quite as much as us, partially, but they're an integral part of the team that's driving SN9, and they're sort of proof in the pudding. This is their work, more than anyone else's to some extent. So massive force for Bittensor in general, and really great guys in general.
Question for SBZ in the audience. SBZ, you're here present, correct? Maybe just type into the channel if you are. I hope so, because you are. Can you tell the Saudis that we beat their model? I know you're in the region. He's typing. I will. Fantastic. All right, great. No shots fired. No shots fired.
But Jake, you say no shots fired. Bittensor beat a nation state. like no shots fired, fine, meta, all of those other things. This community and Tensorplex, shout out to you guys, and the mechanism at hand and market forces did a better job than a nation state that is pouring an immense amount of capital into this problem. And it's easy to gloss over that and laugh and say no shots fired, but shots fired.
Nukes launched. Well said, Will. Well said. Great, guys. Well, where else should we take this conversation? And there's a lot to talk about. There's Macrocosmos in general. There's Tensorplex, your guys' exterior works with the bridge. Will, like I know there's so much going on at Macrocosmos. Tell us more about some of the other subnets that you guys are building, and while we have time on the stage here.
Great. Look, I can speak to that, Const. So right now, we currently are running 3 subnets sort of officially. We've got 1, we've got 9, we registered 25. Shout out to Brian, our lead on that. These are big pillars of the sort of bigger AI and research picture Bittensor. However, we're also with Sid and Rustic, we're also starting to take over 13. And the goal of this really is to create a much more directable data scraping subnet 2. Big part of our picture, as Will put, is we think the next generation, now that we have the APIs, now that the validators realize that their bandwidth is their treasure, and of course we want people to be actually using and integrating Bittensor into their daily lives. We're trying to think carefully about how do each of these subnets provide a sort of a bespoke experience for validators that can be tuned, can be customized through the synapse, that can be, I guess, properly calibrated to real use cases rather than being abstract research projects. So Subnet 1 is quietly plugging into a plethora of front ends as we speak. More news on that very soon. I guess Subnet 9 we've covered in good detail today. And Subnet 25, if I can just speak a moment about that, this is really one from my own heart. I always felt that protein folding and genuinely physical system simulations are a really natural fit for Bittensor because they have certain properties that are they just map really, really elegantly. For instance, in protein folding, it's really, really hard to do the computation that the miners have to do, the proof of work step. Verification is disproportionately easier. In fact, the way that you measure whether or not a protein was successfully folded is that you just compute what's effectively a thermodynamic property. So it's a single number, conveniently like a loss function, and that allows you to measure the fitness or the quality or even the realisticness of your simulation in a single forward pass. So protein folding has been a really exciting journey. We have been kind of Frankensteining the incentive mechanism, beg, borrow, stealing from different subnets. And we've been live for a few days. Of course, we're working out a couple of these zero-day bugs as we go. But what we're quickly learning is this is going to beat AlphaFold 3 very soon. And it's almost terrifying. And I think that DeepMind can hear us from here.
Wow. And
So
how would you measure?
Go ahead, Cons. Sorry.
So how would you measure that beating AlphaFold?
Well, right now they're providing AlphaFold 3 as sort of an on-demand service. Researchers can access it. They have several tiers of access. It's a very strategically designed product. And look, it's great. I'm not trying to bash on those guys. What they've done is truly groundbreaking, and it's something that I personally admire a lot. However, not necessarily for nefarious reasons, but they are unable to provide, let's say, more access to proteins than a few protein folding jobs per day per user. And this is just frankly a limitation of the fact that they're hosting this on centralized servers. Again, it's an efficiency problem and one that's very addressable by Bittensor. Secondly, they have to put caps on the size of the proteins. And this is really important because it's actually the longer proteins that can become more biologically critical and are typically much less studied and are much less addressable. So what they're kind of doing is they're sort of reiterating over a well-known and otherwise quite well understood space of proteins in many cases. Whereas what our protein folding subnet, we hope for it to do, and we're confident that we're going to see those results very soon, is we don't have caps on the number of proteins you can fold. If miners can fold more, they'll make more incentive. It's a very direct line between what we want, which is an unlimited upside, basically how many proteins can you fold at once all of the time forever, and how much incentive you make. So it's really a sort of special case of an applied compute subnet. And of course, as the innovations on the algorithmic side also continue to evolve, right now it's just CPU bound, just big ass process pools, basically. But what's next, of course, is GPU enabled protein folding, which is already something that exists in the software that we're running under the hood. Next step, it's someone's going to start running AlphaFold on our subnet, and then it's a race to the bottom. Everyone's running AlphaFold. Now we have 250 AlphaFolds. What can we do with that? And the fact of the matter is, because it's a sort of self-sustaining economic system within the subnet, we don't have to worry about the kind of caps that are the restrictions that are ultimately limiting the researcher's effectiveness. Did you want to add something to that, Will?
I think that I agree with everything Stefan said. What I would add here is Google came out and said they thought AlphaFold 3 was $100 billion product. And there's a lot of things you can find discomforting about large companies controlling pieces of technology that shape the future. But this is something that's literally affecting the human condition. And a lot of our aspiration with protein folding was to show that Bittensor can be a proving ground, not just for more classical artificial intelligence applications and commercial points, but actually that Tau holders can incentivize important research that is important for humanity. And protein folding was the most elegant answer for that problem for us to start with. But we've coined this program Deep Blue Sky because for us, we think Bittensor is the best force to organize compute around things the community celebrates. And we hope the community will agree with us that solving some of the challenges around humanity, be they folding proteins or solving particle physics or anything else in that domain, are something that Bittensor should be able to do. And that's a big part of both Stefan and my and our team's aspiration. We're both researchers at heart. I'm really excited to see what we can sort of do with this next evolution in incentive mechanisms.
Wicked. I can't believe that valuation. That's incredible, and that's just based on the fact that you can get these proteins folded cheaper, faster. Is that really the main?
I believe it's the breadth of domains it believes it can solve, and the and how many problems they think I think it's how much money they think they can make from it, really, Cons. And it's reflected in the fact AlphaFold 3 is much more limited in terms of its access and use by external organizations than AlphaFold 2 was. And AlphaFold 2 was released in the sort of domain when AI was great and free, and Google still had that emphasis about them, particularly with DeepMind. And the reality is the commercialization drivers are changing that. And I think, you can argue about whether LLMs and commercial products and GPTs should be commercialized. But I think when you're talking about stuff that's going to save lives, there's a greater reason for that to be something that's owned by all people, personally. And I think you can see the challenges that have affected the pharmaceutical sector for years, and many of our colleagues on the call are in the US. I think intelligence is a massive part in solving that problem. And certainly for us at Macrocosmos, we believe it should be more equitably distributed.
Hoorah. Before we end here, I want to hear from Tensorplex about, and you guys are bigger than just mining on Subnet 9. You're doing a ton of stuff across the ecosystem. You're building a subnet. Do you want to talk about that, Darwin?
Yeah, for sure. So, beyond the training operations on Subnet 9, we're also planning to launch a trust minimized bridge. So for this, we would be deploying it on our staking product, and potentially it could be used for other use cases as well. And then on the subnet, we're creating a subnet for the purpose of connecting a human interface for AI, which could be used for RLHF, DPO, training other large language models, or validating the outputs of miners across multiple subnets, especially the ones focused on inference. And I think it would help drive miners to continually improve their models beyond what's the consensus currently. We're still in the midst of testing and finalizing the architecture, so we'll share more about this later on. And then also we're planning to launch a Web3 native LLM in the coming few months, which could potentially power chatbots and decentralized agents.
This is a huge quest in the Bittensor ecosystem to do RLHF, or to generate RLHF data, which is used for fine-tuning language models so that they are more conversational, not been solved. So I'm really looking forward to seeing that design when it's ready. Darwin, we'll stop here for the call. It was awesome to have everyone on stage. Really amazing results from both teams. Thank you so much, guys, and until next time. Ciao.
So guys, thanks a lot. That was a blast. Have a great night, everyone.
Thanks, everyone.
Or afternoon.
Thank you, everyone.
Cheers.